Consider a parallelogram ABCD. AB and DC are parallel and equal. We mark a single line on both to denote that they are equal. BC and AD are also parallel and equal. But since their lengths may be different, we mark a double line on both of them. We need to find the area of this parallelogram. Let us assume DC is the base. To find the area of this parallelogram, we need to do a bit of construction. We draw an altitude from point A to the base DC, like this, and we call this altitude AE. We also have to drop an altitude from point B onto DC. In order to do that, we have to extend DC a bit. Now we can draw an altitude from point B to DC and call it BF. So in this case, AE and BF are the altitudes. We have two altitudes between two parallel lines. As the perpendicular distance between two parallel lines is always equal, AE equals BF. Let's mark triple lines on both of them. From the figure, we can say that these two are equal, these two are equal, and these two are also equal. These two pairs are equal since it's a parallelogram, and these two lengths are equal by our construction. Now let us look at these two triangles, triangle AED and triangle BFC. Both of them are right triangles. The hypotenuse of both the triangles are equal. That's because they are opposite sides of a parallelogram. Both the altitudes are also equal by our construction. If two right triangles have the hypotenuse and one of the sides equal, then they are congruent by the RHS congruence condition. So triangle AED is congruent to triangle BFC. Remember, congruent triangles always have their areas equal. So the areas of these two triangles are equal. We need to find the formula for the area of a parallelogram. That is, area of parallelogram ABCD. Look at it carefully. It will equal the sum of this figure plus this triangle. It will equal the sum of areas of quadrilateral ABCE and triangle AED. As the area of triangle AED is equal to the area of triangle BFC, we can also write it as sum of areas of quadrilateral ABCE and triangle BFC. ABCE is this and BFC is this. The sum of their areas will be this. It will be equal to the area of rectangle ABFE. We know that the area of rectangle is equal to length multiplied by the breadth. So it equals AB multiplied by BF, which can be written as DC multiplied by AE. That's because AB is equal to DC and BF is equal to AE. DC is the base of the parallelogram and AE is its height. So this is base multiplied by height. That's the formula for the area of a parallelogram. To find the area, all we did was draw two altitudes, prove the congruency between these two triangles, and found the area of this rectangle. So the area of any parallelogram is equal to its base multiplied by its height. So if we have a parallelogram ABCD like this, and we draw an altitude from A onto DC, then DC becomes the base and the altitude becomes the height. The area of the parallelogram will then be equal to base into height. Here, we should note that DC is the corresponding base for this altitude. If we had drawn an altitude from C onto AB, then AB would have been the base.